Sophisticated state-of-the-art simulator adds efficiency and accuracy to your overall training program. The simulator can be configured in many ways, allowing you to experience a wide variety of on-the-job multi-situational scenarios. The Transformer Simulator helps you to recognize standard wiring configurations, manually configure transformer wiring scenarios, and check your knowledge of proper transformer wiring. Once you are familiar with the company wiring standards, you'll need to successfully pass the skill assessment section of this simulator to earn completion. After continuing from the company logo screen, you will see 4 icons. The Import a Previously Saved Configuration icon allows you to open previously configured and saved configurations. These files can be accessed locally or on a network drive. The Start a New Configuration icon allows you to manually build wiring configurations. This feature can be used to create customized training and troubleshooting scenarios. The Sample Wire Configuration Examples icon is the company's wiring standards. The list of standards can be brought up, reviewed, and energized. A Show Me button is provided to show the recommended wiring order. The Skill Assessment icon will check your knowledge of proper transformer wiring. The Skill Assessment module has been designed with a multi-point algorithm allowing your configuration to be matched electronically to the company wiring standards. If you are not successful, you can go back and review the company's wire configuration examples before trying again. The questions inside the skill assessment are randomized. This transformer simulator has been designed with easy-to-use menus. When starting a new configuration or reviewing a sample wiring configuration, you can access and change course configurations on both the line configuration and the transformer configuration screens. Line configurations and voltages can vary from location to location. This simulator is flexible enough to accommodate a wide variety of situations in an easy-to-configure control panel. A vector represents the magnitude and direction of the voltages and is represented as a vector wheel. As you choose the type of system you have from the list of grounded Y, delta, and grounded delta, the vector wheel will show either a Y or a delta symbol. You can control both the direction and rotation of the vector wheel. Through this interface, the number of primary and secondary lines, as well as ones that are grounded, can be customized. The simulator covers many possible line configurations out of the box and custom voltages that can be added to cover any situation you may encounter. To add a voltage not listed in the company list, click on Customize. Then put in the number you want to add into Enter Voltage box, and then click Add. You can remove the voltage by entering the voltage you want to remove in the Enter Voltage box, and then click Remove. Line labels can easily be changed to reflect company standards or to match various written material. The current setup has already been set up to match the company learning standards. If you wish to change the labels, highlight the label you wish to change and put in the new character or characters. The customer requirements list will not affect the calculations inside the simulator. However, they provide you with the desired outcome along with a recommended Y or delta configuration. The How Many Secondary Wires configuration tab allows you to add or remove secondary wires. You can turn off the ability to view labels, which will only allow labels to appear after wiring connections are made. Default View sets the preferred view inside the simulator. The Schematic View represents a schematic view with primary lines above and secondary lines below the transformers. Field View represents a 3D field view, which is intended to bridge theory with real life. Explosions can also be disabled. This allows you to test voltages and view vectors in a potentially hazardous situation. Secondary line type allows you to change between different pole constructions. This is only represented in the 3D view and can be changed any time while the simulator retains all wiring information. Vector direction can be set based on your desire for engineering or field vectors. Vectors automatically represent magnitude based on the size of voltage. Choosing a bank. You have the ability to configure and wire a single transformer bank or wire and parallel 2 banks. You can choose which pole to configure first. The default is pole 1. The Transformer Bank Configuration page is an intuitive, user-friendly interface. It allows you to configure the transformer bank, allowing for the flexibility of several variables to be manipulated. This provides for training experiences that can be difficult to replicate out in the field. The number of cutouts appearing on the pole, as well as the number of transformers that can be used, is fully customizable. In addition, Each transformer can be configured separately to simulate a specific type of scenario. Transformer configuration options include the number of primary bushings, the number of secondary bushings, whether internal windings are series, parallel, or manually configured. When setting internal windings to manual, all internal windings will disappear and the user will need to manually connect the wires inside of each transformer. The additive or subtractive polarity of the transformer. The expected primary and secondary voltages which will establish the turn ratio. A kVA setting that will vary the physical size of the transformer. Load current is not calculated in this simulator. You can return to this menu to reconfigure transformers at any time. Once you have accepted all the settings, you will enter Schematic View mode or 3D Field View mode. Vectors are represented on the left side bar, and tools and menu items are represented on the right side bar. The vector sidebar will show vectors when the simulator is energized. The primary and secondary voltage vectors are represented individually, while an overlay view is also provided to show the phase relationship of both the primary and secondary voltages. You can zoom into the vector screen by clicking on the magnify symbol. At the bottom of the vector sidebar, you have the ability to label vectors for visual representation purposes only. This will help to visually set up vector labels for both primary and secondary configurations without having to write them down on paper. The primary vector will be either a Y or delta symbol based on your line voltage type. The secondary vector will be either a Y or delta based on the customer requirement setting. Along the right side of the screen is the menu bar. It will allow you to change between pole 1 and pole 2 when configuring two banks. Secondary insulators are used to hook up two banks together. Because the simulator detects backfeed and out-of-phase relationships between the two banks being paralleled, use the voltmeter to test the voltage before wiring the secondary insulators. Wire options allow you to connect, remove, and move wires. This simulator uses simple point-and-click responses for hookup. When you want to connect wires, press on the Connect button tab. When placing the mouse over each desired point, a label will show the point you are on. If that is the desired point, all you have to do is left-click once with your mouse. Then move your mouse to the next desired point and left-click again to connect the points with a wire. At any time, you can remove the wire by clicking on the Remove button, highlighting the garbage can point on the wire, and left-click the point. This will remove the wire. To connect more wires after removing a wire, you will need to click on the Connect button again. To move or stretch a wire, click on the Move tab, section a directional point on the wire, and drag the wire to the desired location. Shortcut. Right-click anywhere on the screen to get both the Wire Options menu and the tools. The simulator utilizes various tools that would be commonly used in the field and can be found under the Tool heading on the menu bar. The main tools are a voltmeter, a phase stick, and a rotation meter. When connecting a tool, the point-and-click method is also used. Click on the correct tool connection or clip, and then click on the first desired point where you want to place the tool connection. Then repeat until the tool is fully connected. The tool will automatically display a voltage or light depending on the tool used. The vector menu bar can be turned on or off under the Tool heading. The vector diagrams are created dynamically as you connect wires to the transformers. The Actions heading controls the 3D camera views, shows the internal windings, and allows you to energize and de-energize the transformer. You can toggle from Schematic View to 3D Field View while connecting wires in both views. Each time you toggle from one view to another, all wiring connections will remain. In the 3D Field View, presets have been set up to easily move to the left, right, center, and top of the scene. At any time, you can navigate around the entire environment by holding down the spacebar on the keyboard while moving the mouse. With a simple scroll of the mouse wheel, you can zoom in for a closer inspection. In order to view the internal windings, click on the Show Windings tab. The user will now be able to see the internal windings for each transformer in both schematic and field views. The user can zoom in and change windings by clicking on the Tools icon located at the bottom of each individual transformer. The user can connect, remove, and move wires by using the Wire Options button on the menu bar. Each transformer also has an individual color located at the bottom, which represents the vector that is associated with that transformer. At any time, you can energize or de-energize an individual transformer or the entire bank by clicking on the Energize or De-energize buttons. If a short is present, the fuse will blow, and if there is overvoltage present, the entire bank will blow and catch on fire. You can turn off explosions if you are unable to see why the transformer configuration is wrong. You can access the Explosion tab inside the line configuration page. This will allow the transformer to remain energized while showing the vector relationship. Vectors that are outside of the vector wheel represent an overvoltage. This is an excellent tool for troubleshooting. The menu bar also has a simulator configuration section which allows you to access both the transformer configuration and line configuration pages, save configurations to a local or network drive, reset the simulator back to the beginning, clearing out all wire connections, take a snapshot or screen capture and save it as a PNG file. This file can be printed, emailed, or used as a picture inside a manual. The Tab key allows you to toggle from Windows mode to full screen mode and back again. The Exit Program tab will turn off the program. Finally, just below the Exit Program tab is an explosion or short detection bar that will appear if an explosion or short happens. Other key points of this simulator include a virtual lineman will close the cutouts and safely energize the bank. Now that the transformers are energized, the primary vectors show that a floating Y has been created. Floating vectors are represented as moving lines in the vector diagram and show an indeterminate voltage when measured. The secondary vectors can be seen floating with indeterminate voltages. Grounded wires automatically turn green. Wire connections can be made in Field View just as they are in Schematic View. The user is able to visualize how connections wrap around the pole. The clean mouse-driven interface was designed to put the focus on learning, even for people with limited computer experience. Contact points that have a tool connected to them stay highlighted on the vector diagram. The vector diagram can display contact point labels or arrowheads to show the direction of the vector. At the secondary insulator location, when the second bank is energized, the location of its vectors can be viewed. Now that both banks are energized, we can compare both their vector diagrams. It is visually clear that these banks can be configured in parallel. Changing your transformer configuration on the fly preserves your existing wire connections. When one of the bank's secondary connections is grounded, the entire paralleled system snaps to reflect this change.